No, maybe I should stay.
You should get a dog with it.
What are you doing?
Alright. Okay, what we're talking about, we're gonna go through answers here. All of your grades in the grade book are up to date as of this moment. Everything's in 100%. So if you're missing something, you can see what you're missing, or if you have a certain score you want to update. You got to make sure that you are going through and you are actually actively trying to get that fixed. Where's Jared at? He went to the restroom.
You hit it back up.
Oh, you ate the other
Yes,
one.
I don't remember getting it. It's about to hand it back right
I'm
now.
gonna hand back to you today so you can make fixes.
I texted 3 people and asked them.
Did you ever listen? I couldn't
Well,
hear
she
the
had
dog
them,
whistle
but they
so
were
close
just
to my ear.
Yeah, she was like grateful for my. She's like, never mind, thanks for reading. Like, okay, sorry that I wasted your time, I guess.
Jared, what's your
Yeah,
KD?
Cindy, if you had texted me like 10 minutes later, I would have brought you a whole package.
Bring me one of mine.
1.5.
I
actually have a positive.
That's good. What?
No, cherry.
Tomorrow here today? No.
This raspberry is my favorite, we only put a little box of them.
It's
It's
Should I get my mom buy me some?
Can
Can you type numbers in there?
What was it?
Minus 3.
It just might have worked.
Alright. Hey, make sure you have your test out in front of
I
you.
didn't know how to do that one.
Mr. Burris, can you hit the lights for me, please?
So
Thank you.
here's
Literally, if I was.
So, hey, let's go through the answers real quick. Alright. Hey, I know it got a little faded. We can go with it. Just pay attention. I'm going to zoom in here just so you can see this. Okay. How I counted this. You had to have the graphs in the right locations. That's a point.
Here's is wrong, mine is
Okay.
right.
Once you are in your right locations, then what you have to make sure of is that your x-intercepts are right. So you have 2 x-intercepts, it's 2/3 and 1. You have a y-intercept of -1/4. Horizontal asymptote at 1.5, I'll explain that, and then you're going to have an asymptote at 2 and -2. All those parts add up to 12. It's 1 point per item you have to do. Okay, a lot of people they had some of the right stuff written down, or they had they were trying to factor, they just didn't finish it. If your factoring was going the right direction, you might have got a point or 2. You might have missed one for not labeling them. If your graph, you just didn't graph this over here, you ran out of time. That's fine. I counted that off. That's 1 point out of the whole thing. If you missed both, all 3 parts, I counted those parts off, but I'm looking for the majority of stuff. Now, let's talk about horizontal, because I always start with horizontal, then I go to vertical, then I look for the intercepts, then I look for, if there's any symmetry to this object. This object is not symmetric, just because I can tell it's not because of the intercepts kind of give it away. They're not perfectly balanced over the origin. Now, the horizontal. I can look at this problem right away, and since they have the same powers for the x squared, you take 3 and you divide by 2. And so that's 1.5, that's where my horizontal is. And again, it's kind of like a general rule where the tails are going. So I was looking for that in the graph. When I factor the top part, it was 3x and 1x, 2 and 1, and they're both negatives because the back side's the same, the front's negative, so they're both negatives. And they just had to make 5 in the middle, so I just FOILed it out. On the bottom, I factor out of 2. Stop. I factor out of 2. Then I break it up by using the differential, or doing the difference of squares. So it's +2 and -2. The vertical asymptotes are because of these make zeros on the bottom, so it was 2 and -2. We already had the horizontal, and then my y-intercept plugs zeros into every x, so I get 2 over -8, which is -1/4. The x-intercepts are at the top, it's whatever makes these zeros. And then to draw this, that's where you just have to set in a table and plug numbers in. I'm not going to bore you with all the tables I had off to the side, I put them on a separate sheet of paper. But the idea is that I eventually figured out it was going to be above the x-axis over here, above the x-axis over here past 2. In the middle, they're all negative, so it was probably just going up and down. That's pretty much what I figured it was going to do, just because of where that y-intercept and x-intercepts were. A lot of people got the wrong x-intercepts because you had the plus or minus sign in the wrong spot.
I could not.
Okay. That happened, which is a little scary. All right, number 2.
That is a tougher problem to factor. You have to.
Okay, number 2.
Oh, that's what you missed.
Number 2. You had to be close on certain problems here. So the A and B, you just had to be close to my answer. What I mean by close, you had to be within 1. Because it really, you can actually, you can't always see mine. Actually, you can. I was trying to kind of guess where the numbers were. Some people they're trying to guess so close that that they're like, okay, it's about 4 or 3-ish. That's fine. I gave it to you. So at -2, they thought it was 4. I thought it was 3. If you're in the ballpark within 1, I gave it to you. I had some people tell me at -2 it was 1 or something like that. That number's wrong. That 1's like over here. That's not at the number 2. Okay.
That's within 1.
Now B at 0, you're at 7. I had a lot of people putting 8 there.
We gotta learn how to count.
I don't know. Anyway, you had to be close.
Okay, but it doesn't, in their defense, it doesn't state that the thing increases by 1.
Yeah, but you assume because of the 5-year.
But
There's 5 happening.
you're not supposed to assume anything.
Yeah. All right. Or I should say letter C. If we're approaching 2 from the right and left, you notice how they went to 2 different numbers? That's when your limit doesn't exist. So D and E. Okay, next. F of x. It gets to 7 as you get closer to 4. It's 7 or 8. When I drew the line, like I put it, it looked like it was hitting 7, but a lot of people put 8 because they thought it was like right above 4.
Oh.
I kind of went with it.
Wait.
So
Why would
it was 7 or 8. That's kind of what I was saying. Next one. As you approach 2 from the right side, 2 from this side, you're hitting 2. If you're approaching 2 from the left side, you're hitting 3. I had some people tell me do not exist. They are going to a number. They just are not going to the same number. Okay, let's go to number 3.
Yes.
All right. I rearranged my problem so you could see this. I even put a table here in case you didn't really think that it worked. So I rearranged, so it was in descending order. They both have the same power, so it has a horizontal. That means the tails will flat at the horizontal. It's 1 divided by 3, so it's 1/3. Now, if you didn't trust me on that, you could plug in numbers like 100, 1,000. I put 100,000 just to give you an idea. When I plugged those numbers into all the x's, it was giving me these numbers, and that's about 0.3 repeating.
Can you plug in 200? I swear to gosh, I did it and I got a different
But
number.
you got to plug in more than just 1 if you're going to do that.
Yeah, but-
because you got to see where that thing's going towards.
No, I get my 100 was 0.33, but my 200 was different, and I want to see what it is.
200?
I'll try it on my calculator.
All right, let's see if I still have it programmed in my calculator here.
Ooh.
Mr. Ward, why does
It
it
looks
look
like there's ink in my calculator screen.
All right, x squared plus 2x minus 1 plus parentheses divided by 3 plus 3x squared, close that parenthesis. All right. All right, let's go out and let's try the variable. Let's plug in 200.
Yeah.
0.3366499171.
I somehow got 0.084, so I was like, oh, it must be
No.
Mr. Ward.
I think my calculator could do that now.
No. All right, hey, let's go to the second page now. All right, second page. All right, doing the limit here. I kind of went overkill. I'm just kind of showing you what I did.
Overkill.
Oh my goodness.
I wrote out all 3 parentheses. I foiled the first 2, foiled the next one. I still subtract the 64. The 64s are gone.
You should
This
get
is what you're
a
left with on the
that.
top. You divide everything by h. And the idea is this is what I get. And when I plug in zeros, I was getting 48.
Look at number 5. It's in the
Okay, a lot of people were saying it doesn't exist or it equals like 0. I was getting consistently 48 when I typed it in. Now, if you wanted to, just plug in numbers that are around 0 into the original problem to see where it's going. All right. Now number 5. Now number 5. I wrote it out. I foiled this out in my head. Sorry. Subtracted 4. The 4's canceled. I'm left with this divided both by h. So I get 4 plus h. And when you plug in 0, I get 4.
Would you rather have
So-
a hedgehog or a teacup pig
No,
as a
stop.
pet?
Stop.
What is
No.
a teacup pig?
Let's stay on task here. I don't like these random questions. All right. Number 7 or number 6. I factored this thing out by doing the limit formula for the definition. So I found the first derivative. I simplified it all the way down. Here's what I got when I simplified it by plugging zeros and all the h's. Then what I had to do is on step 2, was plug in 3. A lot of people were not finding the derivative. I was going to count a lot of points off for not even attempting to show work. Some people were just like trying to do it all on their calculator. I did want to see that you're actually getting to this. So if you're going to take a retake, you have to show me like what you're getting down to, then I can plug a 3 into it. So when I plugged a 3 in, it was 3 squared times 3, and then you add 4 because all the H things went away because they turned out to be zeros anyway. And it turned out to be 31. I had some people tell me it was 27, and I think you're just guilty. All right.
Did you actually?
Okay. Yeah, a lot of people did. They just forgot like it's still there because they divided by H and they thought it would cancel out.
I
All right.
for every single one.
Now, letter A. If your function is odd, so that's an odd function, they're kind of doing opposites across the origin. If the slope over here is 5, the slope over here is going to be the same number. It's going the same direction. So it's going to be the same 5. If the function is even, your slopes are opposites. We talked about that in class. All right, 12. Okay. Okay, number 12. We have to find the first derivative. So doing the limit formula for 4x plus 6, and then let's see. I'm oh.
Wait, why do you
geez.
go to the second derivative
Oh,
first?
I skipped. Hold on. Sorry.
I was so confused.
Sorry. I didn't realize the page. Sorry, I got page 3 out of order. All right.
Yeah.
It's the way that it. Sorry. It's the way that it scanned it.
That makes more sense.
All right. Sorry. All right. So first derivative. Okay, 4x plus h, 3x plus h squared, subtracting the original function, I FOILed it all out. The items in the back should cancel out, anything without an h should cancel. Then whatever I have here, I divide everything by h, so I got into this, and then I plugged in all the zeros for h's, so it's 4x plus 6.
You can do this stuff in your
You need
head.
4 plus 6x.
Yes.
No, you
Show
cannot.
me.
I can do it for a problem, you just make it up.
Just do it.
Yeah, I know it, Mr. Ward, I know how to do that.
No, until I didn't.
Huh? Yeah.
Okay, don't say anything.
I won't,
Don't say anything, it makes it look
but I know.
Wait,
I
you know-
checked my answers on the test by doing that.
Good.
What
How do you do it?
We're gonna talk about it. Let's check.
Talk about it today so I can apply it to the retake.
We're gonna talk about it once we get past this.
We're
All right.
talk about it.
Okay, number 9. Okay, hey, don't say it, wait. Alright, now, Nicole, I just told you now. Alright, now, x plus h. This other item, I subtract them, the 7's cancel out, the half of x's cancel out. Divided by h, and you have half. That's your answer. I had some people tell me that it doesn't exist here. It does, it was half.
Yep.
Okay, next. Stop for the back. 10.
Stop. Stop.
Okay.
You think you are clearly
Okay.
make a plan.
Number 10, you had to find the slope. The slope started at positive slope, then it eventually hit 0 at about 1-ish, and then it came back down to 0 at 0, and then it went up to positive again. So it was positive slopes until 1, then it went negative slopes until back to 0, then it went back to positive slopes. So it should look like a U shape. It should look a lot better than mine. I was trying to represent what you're getting.
No, he did it right, I just put it,
All
I
right.
put it on negative 2 and not negative 1.
I'm not
Yeah.
gonna try this.
I was just looking at generically, is it the right graph?
Okay.
Because some people might have picked a different number, but if you have the generic thing, you're
Right, yeah, I spaced mine out by 1,
Yeah, you're
by
fine.
like, half.
Okay, 11. 11. Slopes are starting at 0. They're working their way to positive infinity. 0 to positive infinity. The slopes here are positive to 0, positive to 0, and then the slopes turn negative on this side. So positive to 0, and then they turn negative. And then the slopes are all positive over here, and then they end up at 0. Okay? Negative slopes. Sorry. Negative slopes until they get to 0. So negative slopes until they reach to 0. That's what I'm looking for. Generic graphs. If you are that person that makes tables, that's fine. But you should recognize that this problem had 3 distinct pictures because there's 3 breaks in that graph. So same spacing. All right. You go.
I just plugged in number, one number.
All right. Probably was 0.0.
It's like, we're running, no question.
You got it. All right. 12. Okay, you have to find the second derivative. Second derivative here, we start with that 4x plus 6x. So 4 plus 6x plus h minus the 4x plus 8, or sorry, 4 plus 6x. We subtract it, we get down to here. You divide, you get down to 6. Fine, there's your second derivative. The next one. When we start here, we did the first derivative to get to half. When you do the derivative again, this is the part that I think some people had a mistake on. Okay, you started at half. If you actually subtract, you get to 0 here on the top, right? Because there's no h's, plus h's I can plug in. But a lot of people were putting do not exist because 0 over 0. What they're saying is as you get close to 0, not exactly 0, but as you approach 0, what is the answer turning out to be? It's actually approaching 0 slope. Because if you're actually to plug in small numbers.
You can't divide by 0.
You can't divide by 0, but you could plug. I was expecting a lot of people put this, and they did.
I did.
But here's the weird thing.
I put 0.
Okay, it is 0. It is 0 slope. So I want you to see why. Because if my function was half.
So GME didn't work?
No, it's technically not. I allowed it because that's probably what I said in class. But from now on, we're going to see in this chapter why it's not DME on that problem. Is because if my function was half, what that looks like, it looks like this. So here's 1, this is half. This is what the function looks like if you were to graph half. It's just a constant, right?
Yeah.
Slope there is 0. It's just a horizontal line. It's not, because that's what a second derivative is, slope of that graph, of the first derivative graph.
That's weird.
Yeah, so now we're going to talk about in this section why it would not be undefined.
Yes, 1 second.
Okay, so,
So we're carrying this stuff on to the next chapter.
yeah, I mean, this doesn't end. We're going to use derivatives on every chapter.
It doesn't.
All right, I want your test back, and then we're going to start talking about some notes today.
I appreciate it.
Break this in half.
Teacup pigs don't exist.
Yes, they do.
No, they don't.
Yes, they do.
Potbelly pigs exist. No, they are called teacup. Teacup pigs are like, no, potbelly pigs are huge. Potbelly pigs are huge.
Teacup pigs are little pigs that can bend teacups.
Yeah, they don't.
Why would you ever want a hog for a pet? You ever raise hogs? They're nasty, annoying, stupid animals. Actually, they're really smart.
They're like one of the smartest cats.
In reality,
But they're annoying. They're horrible. I have plenty.
Scam.
Can I go to the office now?
Okay, anyways, hey,
Four.
Madison?
Yes,
Yeah, let me measure it
on my
absolutely.
shoulders.
I actually at the beginning, but I thought maybe I should stay for that.
It's a reward.
Yeah, like I was holding it like
Potbelly pigs all day small, no.
I was holding it like this, you know?
I don't
Yeah. Like up on my
Then when you drop.
And then I dropped, he turns around, looks at Justin Cock and goes, shut up.
You gotta be good.
Or when I dropped the
Now, to
desk
understand why.
Thursday, and then he turns and yells at you, but not me. What did
Mr.
you,
Ward,
what did he say? He
the
said,
ink on the screen is spreading.
Thoughts on Patrick Mahomes? Yeah, Mr. Ward, why is there ink in there?
Or what is happening
What they
in my
used.
calculator? So if I break this open, ink will come out?
Yeah, don't do that.
You gotta push.
Not in here.
What?
I'm sure Cup will appreciate the math.
I don't see a crack in this
How
side.
much do you do in rough drafts? Are they actually due?
so do you use points
Don't
back?
do them half.
JB,
What?
did you
No.
do the rough
I
draft?
feel like that's so
Yeah,
nice. I'm gonna point
No, I
back.
told him he needs to be.
Basically, he commented on Jordan's and you said like,
There's just no.
you have to have size 12.
Yeah, he commented on
I at least get
Jordan, it
0.5
says
back.
12. So you guys might not get to cheat the
I don't
system
even
like
think
I
he
do.
told
He commented
Well-
on mine too and said like, you have a good start, but you need to make sure that you either put an MLR and an APA and make sure you set your sources, and if it needs a title page, put a title page. It's like 2 pages.
I didn't do
Oh, so
any
like,
of that, and I think.
Yeah, I did none of
how
that.
does Jordan have?
I have
Oh
no
my
idea.
god!
Like, do I
He's like, did you spell my name right? He's like,
Jordan
yeah.
has
And
mine.
I looked and that's why.
Is this like taking?
I
have to tell you that
but
every
he
time.
turned it in.
Still
I don't
wrong.
know.
Turn yours in.
And I had size 14 Courier new font and I got 100%.
I don't actually know what's it supposed to be on. I haven't read it.
Anything cultural
Running
related.
joke.
Okay.
You can choose
It's
whatever you
7
want.
pages on
Well,
anything.
for you
No, it's actually
Yeah,
not
I
just
did
geometry, but what did she
Oh,
say?
really?
You didn't
Yes.
He has to back me down to
Yes,
this.
But mine was
Okay.
Would you like
really
walk
good
over
paper
and
and I realized
I was telling you about
Hey, Sid.
I cut
Oh,
the
You know why I threw that one away? Because I spelled correctly the first time.
And I did like.
Alright, okay.
I'm gonna do a marriage.
Alright, real quick. Can you have the lights for me, please? Alright, we're going to talk about first derivatives, second derivatives today, but I'm going to show you the shortcut.
Mr. Ward, did you guys drop my calculator from this high? What about this?
Stop asking me about the stupid calculator, I'm kidding.
Oh,
What did he say?
He said, stop asking about the calculator. I don't care anymore.
So I could throw it
So-
and you wouldn't care.
I carry a computer in my class. All right.
But don't sit in
Now,
this class.
we're in section 3.1. We're gonna be talking about the rules for derivatives. Differentiation.
That's quite the word.
Okay.
Somebody makes up like 6,000.
All right, the goal today is to talk about the rules. We're gonna intro 2. On Tuesday, we're gonna practice them kind of hands-on. Wednesday this week, there's gonna be a bunch of teachers in here kind of watching the lesson that day.
Wait, a bunch?
Yeah, quite a
Define
few.
a bunch.
6, 7.
Is it because you're a model backslash teacher?
So, yeah. Now, that day will be more like hands-on. We'll be probably working on an assignment that day, but it'll be a different format. Now, there'll be lots of different things we're doing that day. It's just because the homework I'm just going to assign in class. We'll do it in class together. And then Thursday and Friday, I think that's pretty much normal. So it might be one of those days that I won't be in class.
What?
Where you'll probably have a sub one of those days because I have to be in a different class and watching somebody else.
What do you
So
think
it's
they'll
kinda
teach
like
us?
Who's watching you?
So,
Can you give us a list of who's watching you?
No.
Why not?
because I don't know myself. So, all right.
Don't- Whatever you do,
Now,
don't get
rules for differentiation. Let's talk about the sum and difference rule. Okay, so we're gonna talk about sum and difference. And the main rule I want to get to today is called the power rule.
I know that one.
This is the main rule that I use when you guys were always asking about the first derivative, second derivative. This is the go-to rule that I have. You want this rule, it makes doing derivatives way, way simple. But there's little tricks you need to know. Okay, and it comes down to just really understanding
I don't know.
this stuff.
Probably not.
Okay? All right.
I don't know.
So let's talk about this. Okay.
I've just been
I want to
reading
find
it.
the first derivative. So this is what I want to find for this function.
17x plus 34y.
Let's go with
Yeah,
4x squared plus 2x minus.
16.
All right, let's go find that.
16.
It's gonna be
So no, not it does it. Okay. Now,
Oh, I see it already.
8.
okay, hold on. So as we go through this, I want to show you the real way to do it. Then I want to show you the shortcut.
Don't we already
So,
know how the real way?
The real way is the one we know as of right now.
No.
The real way is doing this one.
So why do you have to show us?
So there's a different railway?
there's a big
There's a
one.
shortcut.
Yeah, it's an artificial way per se.
Okay. All right. So it's a limit as h approaches 0. That's the first derivative. First derivative is also known as f prime or d dx.
You're gonna need a
So stop. So it's d dx of this original function here. And so this item would be written in here. That's what differentiation is. Okay? Stop talking. Now, to go through this. This is 4x plus h squared plus 2x plus h minus 5, and we're going to subtract 2x squared plus, that's 4x squared. 4x squared plus 2x minus 5. All right, and this is all on the bottom, or on the top of h.
Can you go to the H?
Yeah, why is the h like awkwardly to the
Because I
left?
don't know how far. All right, so if we go through the limit here and we actually simplify, I'm going to do a lot of this in my head. Foiling this out, this is 4x squared plus 8xh plus 4h squared. That's doing this item, foiling it, then just doing the 4 over it. Then plus 2x plus 2h minus 5. Then we're going to subtract the 4x squared, subtract the 2x, add the 5 in the back because I distribute the negative sign. All over h, and I have a limit as
And
h
don't forget
approaches
to
0.
write it, you're kinda wrong.
All right, so at this point, a lot of people get stuck right there. It takes a lot of steps to get to this point. You have to notice that the 4x squares cancel, the 2x's cancel, the 5's cancel, and what you're left with is 8xh plus 4h squared plus 2h. So the h, this is the limit, as h approaches 0. You divide everything by h. So if we divide everything by h, we're going to be left with 8x plus 4h plus 2. And then we plug in zeros for all the h's, because we still have to do the limit as h approaches 0. This is what we get.
Part of you.
Like that's the first derivative. Okay, so f prime of x is equal to 8x plus 2. Here's the goal.
Resetting.
The goal today, now that you've seen that original problem, that's like the real way that we're supposed to learn. That's the limit definition of it. There is a shortcut, it's called the power rule, but it applies to addition or subtraction. And we can do it very, very quickly on a problem, and I want to show you how this works. So, we're going to go back to this original problem. The 4x squared plus 2x minus 5. Alright, so here's how it works. If it has an x, the rule is, and you can break this up, so what we're doing is we're finding the derivative, doing the power rule, over 3 separate items. Does that make sense?
Yep.
Okay, so if it has a variable, the rule is, this is the shortcut, you drop the power out front. So the 2 will drop out front with the 4, and they're being multiplied. Then what you do is you take the power and you subtract 1 off of it. It's always 1. You're going down by 1 power. Because that's what happens when you do a limit, everything is going down by 1s. So if I start with a 4th power function, it'll go down to 3rd root when you actually go through. Okay? So there's the first part. Then we have the plus. Then the same thing here. You drop the power out front. So in this case, the 1 will drop out front with the 2. And then you're going to subtract 1 off the power again. Whatever the power was, you subtract 1 off of it. And if there's any constants, since it doesn't have a power, it's really a power of 0. You're dropping a 0 out front. And when you take 0 times anything back here, it doesn't matter, this will go away and it'll turn out to be 0. Does that make sense?
Yep.
Yeah.
It didn't matter that you're going to get a negative power, like 0 minus 1. Okay, so now that when we do this, this will get me to my final answer. This will actually get me to
8x plus 2.
8x.
Easy.
This will be a 2, and the x to the 0, so that x to the 0 will just turn out to be a 1. So, it's a shortcut for getting there. But again, you have to know the rule. It's called the power rule. You can do it for any polynomial. Now, it is simple. But the trick is you got to know the actual rules behind it. Okay, hey, let's pick up all that stuff off the floor.
Why
What
did
are
I
the
mess
limits?
with something?
Do I know this?
Okay, what?
Do I know all the little?
Now, this rule of differentiation makes the problem so much easier when you actually see the actual rule kick in versus when you don't. So doing the limit stuff can be long and lengthy. It is, okay? But once you actually get the shortcuts done, it goes a lot faster. The problem is that I can foresee happening. Forgetting that you have to subtract 1 off the powers, or forgetting that this x will turn out to be a x to the 0, which is 1 and not 0 itself. It's kind of everything that you're doing, all the x's are always dropping down. This rule doesn't work when we start multiplying items together or dividing. There is a trick for doing those that have their own separate rules. No, when you're multiplying items, it's called the product rule. When you're dividing items, it's called the quotient rule. And when you have a power on a power, they call it chain rule.
Why don't they call it the power?
So, because it's a chain reaction, what would happen?
Ooh, chain reactions. What's your favorite element?
So, all right. So, okay. All right. Questions right now on the shortcut.
Nope.
Okay, I'm going to put one on the board. If you get this right, other than Jane, because she wasn't even here, we're done for the day.
Jade, you're in.
No, okay.
Jaden is.
All of us have to get it right?
All you have to get it right.
Do I have to write down on a piece of paper?
Yes,
I do
it
it
has to be
right.
on a piece of paper in your notes.
What if you just do it in your head? Jaden's
I want it on paper, and you got to write this down to show me that you can do it.
Please
All
go.
right, what?
I'm gonna write out when I do anything else.
Okay, Jane doesn't count because she wasn't even here.
Oh, so
Can I
Jaden
attempt
has
it?
more?
Yes.
Just do
On the
the.
board.
Just do the normal way. You'll
Just
get
look at that.
Just do the normal way and then do it.
With paper. All right, here we go.
I'm gonna answer it already.
Okay, here's your function. Then I'd like you to do your chain rule.
FX Shire.
I'm not
Oh
even-
god.
Yes,
Lord,
That's
seriously?
not cool. That's just lame.
No.
Oh.
Oh, what?
What are you
I'm gonna make a
doing?
percent.
Do you have to plug in?
You don't have to plug it in. I just want to know, doing the shortcut, what's your first derivative?
So we don't have to substitute?
Shortcut. Oh.
Doing the shortcut, what would the first derivative be?
Okay.
I'm looking at this, I can probably figure it out.
I'll be impressed. You can get this figured out without me explaining.
Show me. Got it, Mr. Ward. I beat him.
I'm done.
No, shut up. Maybe you should do what I was saying on the floor.
To the 7
Huh? Yeah.
minus.
I wrote the whole shebang.
I know you agree.
I forgot to write.
If anyone got it wrong,
What did you get?
show me.
Why?
No, like
I'm
any
so
of
upset.
Why?
That's what I got.
I had a really good circle and I forgot to write the
Are you
little.
getting these?
I feel like I got it.
Oh,
Mr. Ward, I'll put it in your basket.
Lord, I'm gonna do this.
I'm scared.
Super
You
impressed.
don't want it in your basket?
First round pick.
Did you say I should dab?
First round pick worthy. He was a first round pick. Yeah, not first round pick.
Don't do that. Don't snap my calculator.
Really?
I want to snap
You
it.
just snapped it.
Yeah, Ward, did I get it?
Reese, I was gonna snap my calculator.
I'm gonna
Fuck, did I get it right?
Ward, that I'm not as stupid as you think.
Let me see it.
Don't worry.
I've never said you were stupid.
You.
No.
You said our whole class was stupid.
A good little weak spot.
You always think we're stupid.
You said
me, Justin,
I
and
have
Lucas were
ultimate
What's 8
faith.
times 3?
Mr. Ward hates me.
I really.
Justice.
24. I know, I didn't know either.
I don't just like fake.
They cheated the first
I'll be
round.
impressed.
My notes are away, Mr. Ward. I can't do anything else.
She is doing it.
Rest of class, talk about
35.
crazy topic called slope.
Everybody hates Kansas City Chiefs. Give me this.
False.
I'm gonna
Mr.
throw this
Ward.
one.
Mr. Ward, sir.